We want to evaluate the double integral over the region R defined here by identifying it as the volume of a solid. Notice how the region of integration R is a rectangular region defined where x is over the closed interval from 0 to 4 and y is over the closed interval from 0 to 3. Let's first sketch the region of integration on the xy plane shown here. So x is on the interval from 0 to 4, and y is on the interval from 0 to 3, which gives us this rectangular region in the xy plane. Next, notice how the integrand function f of x comma y equals 2x is non-negative over this entire region, which is the reason why this double integral is the volume of a solid. If the function was negative over this region, we could not interpret this as volume. Let's take a look at this graphically. f of x comma y equals 2x is graphed here in blue. If we look down on the xy plane, this is the region of integration. So our double integral gives us the volume under this blue plane above the xy plane over this region. So notice how this solid would be a right triangular prism. Now let's go ahead and find the volume of this solid. The volume is going to be equal to the double integral of 2x. Now we need to decide whether we're going to integrate with respect to x first and then y, or y first and then x. We'll actually show both. If we integrate with respect to x first, we integrate with respect to x from 0 to 4. Then we integrate with respect to y. We integrate with respect to y from 0 to 3. This would give us the volume of the solid, but if we change order of integration, we would also get the volume. We can also write this as the volume is equal to the double integral of 2x. If we integrate with respect to y first, we'd integrate from 0 to 3. Then with respect to x, we integrate from 0 to 4. So it doesn't matter which one of these we use. Let's evaluate the double integral in this form here, which means we integrate with respect to y first. So the antiderivative of 2x with respect to y would be 2xy. So we have the integral from 0 to 4 of 2xy, which we need to evaluate at 3, then 0, and then find the difference. And we're subbing these values in for y, not x. Making the substitutions for y, we would have 2x times 3 minus 2x times 0. So this gives us the integral of, this would be 6x minus 0, which is 6x, integrated with respect to x from 0 to 4. Now we integrate with respect to x, so we'd have 6 times, this would be x squared divided by 2, which simplifies nicely to 3x squared, which would be equal to 3 times 4 squared minus 3 times 0 squared, which is equal to 3 times 16, which equals 48. So this 48 represents the volume of the solid below this blue plane and above the xy plane over this region in the xy plane. And of course, because it is volume, we could include units as cubic units. Of course, if we wanted to, we could also evaluate the double integral using this order of integration, and we get the same result of 48 cubic units. I hope you found this helpful.